Good afternoon. So we're going to do another Thevenin problem. So here's the original problem. What's the first thing we do at Thevenin is we remove the load and get voltage A to B. So I've already put my load component over there. I'm going to remove it from here. So to get voltage A to B, I'm going to do it this way. So I need the voltage across that 4K ohm resistor, and to me the easiest way for that is to use mesh. So we have here I1 and I2. I2 multiplied by the 4K gives us the voltage here, okay, and then we know it's going to be plus to minus based on the direction of the source. So I wrote the mesh equations already. So this is anything touching I1, which is 5K and 450, minus anything touching I1 and 2, so this is this component, equals 20, because if we're entering negative on the other side of the equation, we have a positive. For the I2 equation, it's negative anything touching I1 plus I2. Then for I2, it's any component touching I2, which is these three components. There's no voltage here, so it's 0. When I put these in simultaneous equations, two unknowns, I got I1 and I2. I2 would be the current for this 4K ohm resistor. Once I take 442.11 microamps at that angle times 4K ohms, I get some number. What is the number? What did I get? 177. Yeah, that's it. 1.77 volts at an angle of negative 79.96. I've put it over there before. Okay, so now I can get my voltage A to B. Although this is open, remember you always have to count that voltage source if it's within your path. So it's a plus 23 at 0, plus 1.77, and now you're at B. So your VTH would be 23.37. So we'll put this here in our Thevenin equivalent circuit, 23.37 volts at an angle of negative 4.28. So that's our VTH, also known as voltage A to B, okay? We still need to get ZTH, which is also known as Z total. Voltages get shorted, okay? Currents are open. We don't have any current, so that's a short there. This is a short here. We put our fake battery there and we minimize the circuit. Okay, so the first thing we see is this 5K in parallel with 450 at an angle of negative 90. We have to put these two in parallel. Remember, when you're putting a source that has an angle, this has to be in parentheses. When you put those two in parallel, you get 448.19 at an angle of negative 84.86. That answer would be here, and it would be in series with that 100 ohm at 90 inductor. So 448.19 at an angle of negative 84.86 plus that 100 at an angle of 90. When we add them together, we get 348.71 at an angle of negative 83.38. Okay? So then that number would be here, and it's in parallel with the 4K. So we put 348.71 at an angle of negative 83.38 in parallel with 4K ohms to get our grand total of 348.98 ohms at an angle of negative 78.48. And that is your ZTH, also known as Z total. So we're going to come over to the Thevenin equivalent circuit, and we're going to put 348.98 at an angle of negative 78.48. So now we have completed, this is plus to minus because it was a positive. We have completed our Thevenin equivalent circuit. The last thing we need to do is get the voltage across this load within the Thevenin equivalent circuit. And we can just use the voltage divider rule. We got 23.37 at an angle of negative 4.28 times 200 at an angle of negative 90, divided by this plus this, which is our Z total, 348.98 at an angle of negative 78.48 plus 200 angle of negative 90. Okay, and when we do that calculation, you should get 8.55 at an angle of negative 11.61. This is what we're looking for. This is the answer. This is the Thevenin equivalent circuit. All of it needs to be there on your test. That's it. Have a great day.